Our Earth's inner core rotation is slowing down and reverses direction. What does this mean for our planet Earth here? Earth's inner core, the solid iron sphere nestled deep within our planet, slowed its rotation according to new research. Scientists from University of Southern California say they're discovering challenges previous notions about the inner core's behavior, and it raises intriguing questions about its influence on Earth's dynamics. So what's going to happen to us? The inner core, the mysterious realm located nearly 3,000 miles beneath our feet, has long been known to rotate independently of the Earth's surface. So what happens then? Scientists have spent decades studying this phenomenon. They believe it to play a crucial role in generating our planet's magnetic field and shaping the convection patterns in the liquid outer core. Until now, it was widely accepted that the inner core was gradually spinning faster than the rest of the Earth. It's a process known as superrotation. But this latest study, published in the journal Nature magazine, reveals a surprising twist in this narrative. John Vidal, Dean's Professor of Earth Science at the USC Dornsife College of Letters, Arts and Sciences, said in a statement, "When I first saw the seismographs that hinted at this stage, I was stumped. But when we found 24 more observations signaling the same pattern, the result was inescapable. The inner core had slowed down for the first time in many decades. Other scientists have recently argued for similar and different models, but our latest study provides the most convincing resolution," he said. Slowing spin and reversing rhythm? By analyzing seismic waves generated by repeated earthquakes in the South Sandwich Islands from 1991 to 2023, the researchers discovered that the inner core's rotation had not only slowed down, but had actually reversed direction. The team focused on a specific type of seismic wave called PKIKP. It traverses the inner core and is recorded by seismic arrays in northern North America. And by comparison, the waveforms of these waves from 143 pairs of repeated earthquakes, they noticed a peculiar pattern. Many of the earthquake pairs exhibited seismic waveforms that changed over time, but remarkably, they later reversed to match their earlier counterparts. This observation suggests that the inner core, after a period of superrotation from 2003 to 2008, had begun to subrotate or spin more slowly than the Earth's surface, essentially retracting its previous path. The researchers found that from 2008 to 2023, the inner core subrotated 2 to 3 times more slowly than its prior superrotation. The study's findings paint a captivating picture of the inner core's rotational dynamics. The matching waveforms observed in numerous earthquake pairs indicate moments when the inner core returned to positions it had occupied in the past, relative to the mantle, and this pattern, combined with insights from previous studies, reveals that the inner core's rotation is far more complex than a simple, steady superrotation. The researchers discovered that the inner core's superrotation from 2003 to 2008 was faster than its subsequent subrotation, suggesting any asymmetry in its behavior. This difference in rotational rates implies that the interactions between the inner core, the outer core, and the mantle are more intricate than previously thought. The limitations and pieces of the core puzzle? While the study offers compelling evidence for the inner core slowing and reversing rotation, the study, of course, has some limitations. The spatial coverage of the seismic data is relatively sparse, particularly in the North Atlantic, due to the presence of chert layers that hindered continuous coring. And furthermore, the Earth system model used in the study, despite its sophistication, is still a simplified representation of the complex dynamics at play. The scientists emphasize the need for additional high-resolution data from a broader range of locations to strengthen their findings. And they also called for ongoing refinement of Earth system models to better capture the intricacies of the inner core's behavior and its interactions with outer core and mantle. Now, what do the findings mean for the future? The discovery of the inner core slowing and reversing rotation yields major implications for our understanding of Earth's interior and its impact on our planet's dynamics. The inner core's behavior is closely tied to the Earth's magnetic field and the convection patterns in the outer core. And the study also raises fascinating questions about the potential consequences of the inner core's changing rotation on Earth's surface. What does this have to do with our mantle and the Earth's surface? Could these variations in rotation affect the Earth's magnetic field, the climate, or even the length of our days, let alone devastating earthquakes or volcanic reactions, I would add here? Vidal suggests it's possible the change could lead to changes in the length of a day by fractions of a second. It's very hard, he said, to notice on the order of a thousandth of a second, almost lost in the noise of the churning oceans and atmosphere, he says. Future research will, of course, explore these intriguing possibilities in greater depth. And he says the dance of the inner core might be even more lively than we know so far. And this is on Study Finds by Editor-in-Chief Steve Fink. Please leave your comments. Thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.